So, you've been asked to find the foci of an ellipse. Don't panic, you can do it. Foci, foci, Jedi. Either way, we're going to use the Force to answer this question, and you will do fine. First thing, let's talk about basic mechanics of how ellipses work. Generally, you have an equation such as x minus h squared all over a squared plus y minus k squared all over b squared equal to 1. If you get a funky equation where it's not equal to 1, it's equal to 6 or something like that, you can just divide both sides by whatever value this is to turn it into a 1, and then you'll have the general form of an ellipse. And this is very useful because this a and this b tell us some useful information. In particular, let me draw an ellipse here. Here's an ellipse. The longest axis, in this case the x-axis, is called the major axis. Here we go, let's draw that line. We'll pretend that's in the center. Or we'll put it in the center. Yeah, that's how it's going to be. And the shorter axis is called the minor axis. In this case, it's the y-axis. There we go. The foci are exactly the same distance apart from the center, which we already know is h comma k. And here's the really cool thing. If you put this into standard form so that this says 1, then this a is this distance right here. That's a, which means this is also a. So the distance across the axis, the horizontal axis, is 2a. And the distance across the, in this case, minor axis is 2b. Or not 2b. Ha ha ha. That is the question. Alright, so we have some information about the basic mechanics of how an ellipse works. This thing will be called a covertex or a minor covertex. This will be called a major vertex. So we will determine the foci of this ellipse. Now let's actually draw this. We already know right off the bat that the distance across here on this ellipse is going to be 8. And the distance across here on this ellipse is going to be 6. Okay, because A in this case is actually 4, and B in this case is actually 3. 2 times 4 is 8, and 2 times 3 is 6. Okay, so now let's actually draw this thing, and I've done that on a graphing calculator because it's a little nicer looking. We already know the center from looking at this is negative, oops, you can't quite see all of that, is negative 13, comma, positive 1. So if I plot the point negative 13, that's 12, positive 1, we should get the center, which we do. Beautiful! And the major axis occurs along the line, ooh, that looks like y equals 1, which we already knew because this is 1. And the minor axis is x equals negative 13, I do believe. We already knew that because that. Check it out. Now we're going to take this guy. We're going to paste it into our little document here, and we're going to work on it. So we already know how long this guy is right here. That's B. So that's 3. And the one on top is also 3. Wow, that's a terrible French brace. And then we already know the distance for A. I'll make this green just to make it more clear. The distance for A here, ooh, that's a better French brace. That guy is 4, along with its counterpart on the other side, a horrible French brace person, and that is 4. So we know that this is 3, 3, 4, 4. Now what? Well, you see, the focus is going to occur at some point along this line, along the major axis. Let's make the focus orange. We'll pretend it's right here. We don't know for sure exactly where it is yet, but we're going to pretend. We do know that the focus is exactly the same distance from the center on both sides. We also know that the focus can be calculated using a fancy formula. Watch this. If you make a right triangle up to here, we know this point. We can actually draw that out. That's negative 13 comma 4, making this distance 3 tall. And we know this distance. What we don't know, question mark, is this green distance. What is this? Well, this is the distance from the center to the focus, question mark. This is a right triangle, super cool. We can use our friend Pythagorean's awesome theorem that he stole from the Chinese or the Indians. We know, we'll call this maybe, just to match up with our previous formula up here, we'll call it A, because it is. If you don't believe me, I'd love to explain it to you. It has to do with the definition of an ellipse. Out that both of these lines have a distance of A. Just take my word for it. It's A. This has a distance of B, which we already determined. It's right there. It's 3. We already know that A is 4. So we have ourselves a fancy schmancy right triangle for which we can solve for the missing side C. Let's do that. C, we don't know, question mark. We know that A squared plus B squared equals C squared. We're trying to solve for C, you know, and just to make things a little bit less confusing, in a normal Pythagorean right triangle, C is going to actually be the hypotenuse. So just to make sure that we're not super confused about what's going on, I'm going to relabel these so that this is following Pythagorean theorem conventions instead of this formula convention. So we'll call this C, we'll call this B, and we'll call this guy down here A, just so we don't get confused. Okay, so A squared plus B squared equals C squared. We want to solve for A, so let's subtract B squared from both sides. That gives us A squared equals C squared minus B squared. And now we simply need to plug in the numbers that we have, or I suppose we could square root both sides if we want to. A equals plus or minus, you get one of those when you square root stuff, B squared. And we'll plug in the numbers we know. We know that C is 4, B is 3. Once again, C is this guy right here, and B is this guy right here. One of them got to keep its original name. The other one got married and changed its name, apparently. So we have A, which we're looking for, we don't know, equals plus or minus the square root of 16, which is C squared, minus 9, which is B squared. And of course, 16 minus 9 gives us 7. So A equals plus or minus root 7. We are almost done. To find the coordinates here, we know that this center point, once more, I'll do this in black. The center point is negative 13, comma 1, right? We're going to go right square root of 7 from there to get to this guy. So we're going to take this and just add square root of 7. And that's our coordinate point. And to get to the other side, we're just going to go left square root of 7. So we'll say minus square root of 7, comma 1. And we're done. Look, we found the focus. Foci, Jedi. The process is similar if you're using an ellipse where the major axis is on the y, but you would be adding and subtracting this value on the y axis. If you need to draw a picture, it will help you to understand what's going on. Good luck!